Patrick Cook here. Welcome to session number 6 of our Mastering Mandelbulb 3D Formulas tutorial series. Now, in the previous session, I was talking about iterations. All right, and I think you have a pretty good handle on that now. All right, whereas the iteration count is the number of times up to that a formula will be run or executed. Okay. The min and the max iterations is the number of times up to a formula set will be run. Okay. Combined, those two make some very interesting graphics up on your screen. Now, there's another concept which is important, all right, and it's called our bailout. Now, the R doesn't really mean anything to us, okay? It's a term that goes back into deep math, and the term is important for those people that really understand the whole math behind this thing. For our purposes, just the term R bailout will be sufficient to kind of understand the concept behind all of this. Now, all right, let's talk about the R bailout. Let me get my whiteboard up here so we can see what we're doing. All right, get my stylus here. Oh, I gotta raise this so I can see it. Okay. All right, so the R bailout. All right, here's what happens generally. All right, let's say, okay, so we're gonna have a graphic object, a Mandelbulb object that's going to be on the screen. Now, there's going to be some formula that is going to be executed in order to make that graphic. I don't know, let's just say z plus z squared equals, and then, the output, okay, something like that. And what's going to happen is our iteration count is going to actually execute this formula over and over and over again. That's iteration count. Now, we're not talking about the min and max iterations right now. That min and max pertains to the number of times the whole set or all of the assigned formulas will run. Here I'm talking about the one formula. Okay. So there's going to be an output. All right. It's going to this output is either going to be within what's called the orbit or outside of the orbit. Now, what that really simply means is this, that there will come a point where the output of this equation will be able to create a dot on the screen. All right. And that dot, if it falls within the limit, will be written to the screen. If it does not fall within the limit, it will not be written to the screen because it'll be out here, somewhere out here in infinity or an extremely high number. This limit is determined by the R bailout. That's the limit that I was just referring to. All right, so if the equation is run, a point is calculated, and that point will be converted into a pixel on the screen. If that point, or the pixel, is within the R bailout, it will display. If it's outside of the R bailout, it won't display. So the R bailout is actually the point at which pixels or points, the point at which points, it's the point at which a pixel will not display. All right. So that's really all what the R bailout is. Basically it's saying, look, you're too far out. Don't display anything. All right. Now let's go back over to our interface here. And I just want to point out, if you take a look at this graphic right here, this Mandelbulb object, this is the cosine POW2, all right, and that's currently assigned to the Mandelbulb. Actually, no, we don't want to do that. We don't want to do that. What we want to do is we want to go back. I want to reset and recalculate. I want to keep this simple for you now. Okay, I just reset. I just wiped out all of the assigned formulas, and the iteration count was set back to 1. Our bailout is set back to 16. Okay, all I want to do is show you this. So this graphic right here, all right, basically what happened is that the formula integer power assigned to formula slot number 1 was run with an iteration count of 1, so the formula ran 1 time, boop, like that. All right, with an R bailout of 16. So if you can kind of envision this, all of this blue area right here, there is no dots, there's no pixels, because this Mandelbulb graphic was able to form on the screen with 1 iteration of the formula with an R bailout of 16. So that means that all of the pixels or the points that goes into making up that this particular Mandelbulb object, the whole thing was accomplished with 1 iteration of the formula with an R bailout of 16. All right. Okay. So there's 2 basic fundamental elements that go into the creation of a Mandelbulb object when the Mandelbulb3D executes the formula, runs the formula. That's the iteration count, and also the R bailout. Now let me prove it to you. We got a few minutes left here in this session. Let me do this. R bailout of 16. Okay. Let's make an R bailout of half of that, 8. Now I need to come up here and calculate. All right, so I need to run this. So let's do that. That was an R bailout of 8. Our graphic still fully formed with an R bailout of 8, which tells me that an R bailout of 16 was not necessary. Let's half that, and let's half. Let's divide 8 into half. 4. Now let's punch it. All right, my Mandelbulb object still essentially completes with an R bailout of 4. Let's cut that in half again. 2. Calculate. All right, there is a difference here. You notice how the color is starting to change now? All right, now watch this. I'm going to put this back to 16. Just keep an eye on this, and you can see the color difference. Calculate. All right, you see how the blues are lighter, the greens are lighter, because the number of times that the object will iterate and create these points. These points have an effect on the color of the object. All right, now let me get down here and let's put an R bailout of 1 in here. Let's see what happens. Very interesting. Okay, so what I've done here is I've created an R bailout that is so low that what it's telling you, what's happening is that let's get the let's get our whiteboard back up here. All right, take a look at that. Now, you'll see here that with an R bailout of 1, which is what I just put in there, it's very, very kind of fuzzy. All right, it's it's out of focus, okay? It's fuzzy. Because what I was doing here is I was not allowing all of the pixels to properly display because the formula equation went outside of the R bailout, and many of my pixels can't display anymore. And so that's the reason why this thing is so fuzzy like that. All right. So let me do this. Let me go back to 16. Let's take a little extra time here. Calculate. And I want to do something else. I want to punch this iteration count up to, I don't know, what, 50? How about 50? Punch it. No difference. No difference. The reason is because 50 iterations was not necessary to create that Mandelbulb fractal object, and therefore you're not going to get 50 iterations. It's going to stop when it hits the R bailout. Let's put that R bailout to 1. Calculate. We're back to our fuzziness. Again, it just goes to show you that this iteration count is not giving us any better results. So the iteration count and the R bailout have a lot to do with how this Mandelbulb object is formed on the screen. Okay? All right, let's continue this fun in the next session, and we'll continue to talk about all of this stuff, and it's going to get more and more interesting as we go. I'll see you there.